Hello everybody, this is lecture 7 of the Introduction to Electronics by Mr. Amar Abdulbari from Electrical and Electronic Engineering Department, Nearest University. Today we will speak about chapter 6, which is speak about the series parallel network. So previously we speak about the series circuits as a series of resistance, and later we speak about the parallel circuits, which is a parallel components of resistance. Now we speak about a more complicated one, which have a series and parallel in the same circuit. So we define something called a branch. Branch is a part of the circuit that can be simplified in two terminals. So if I have a point here, sorry, if I have a point here and I have a point here, between these two points I can specify that these 2 points have called a branch. Okay, whatever inside, maybe it is resistors, voltage sources or other elements, between these two points or terminals we call it a branch. Okay, now complex circuits is maybe have both series and parallel elements. Other circuits combination between both of them. Now to analyze a circuit that have a series and parallel elements, we we will use the same analogy that we use it in series circuit and in parallel circuits. So here you can see that this R2 and R3 and R4 is in parallel, so you can calculate the equivalent circuit, equivalent resistance RT, and the total the parallel combination, this combination is in series with R1 and in series with R5. You see, this is how we can deal with complex circuit. Okay, now in this circuit again we see that this R3 and R4 is in parallel. R3 and R4, maybe you can write R3 4. Okay, R3 4 is in series with R2, and the equivalent for both of them is in parallel with R1. Okay, so if you want to calculate the R total that you see it from this point, from these terminals, you will have to take it step by step. Calculate the parallel here using the equation for two element or two resistors in parallel, then take it in series with this and we just summation, and then we take the total of all of these three in a parallel with R1. Okay, so again the rules is the same, still apply. Same current is occur across all series elements, same voltage occur across all parallel elements, and for the difference you will use Kirchhoff voltage law, Kirchhoff current law to apply for the other circuits, or you just apply it for series branches or parallel branches. Okay, so to analyze it again, you redraw the complicated circuit as shown and label all label all points, and best to begin with the component most distant from the source. So you have to start from the component that's away from the source and try to simplify it until you end with one equivalent resistor that have the same terminals with the source, the voltage source. Okay, so you determine the R total, you solve the total current. If you have the total voltage, you can divide and have a knowledge about the polarities of the voltage drops across each component, and then you just divide the current and divide the voltage split between elements. Okay, so here for example I just combine R2 and R3. Okay, so I see equivalent here. This equivalent have the same voltage V2, and this one have the same voltage, but the current is still the same from this point to this point is still the same, but here there is a current divider. Yes, if you remember from last lecture, so the current in R2 is different from R3. Yes, and the voltage here is different from the voltage here. So you know that you if you want to calculate I3 and I2, you have to know V2. Yes, and V2, if you want to know it, you have to know the R total. So you use the total voltage to divide it between these elements. Okay, so that's how we know for each element what is the resistance, what is the voltage, what is the current in each component of the old circuit. This is a simplified one. To find here, for example, you see here that this is the total one. You see here that this one R1 and R4 is in series, R2 and R3 in series. However, both of them here is equivalent with R1 and R4, but you have to draw it simply. Yeah, so we can redraw this to take the voltage to the left hand side and make some points here, for example, and I will take from this point R2 and R3, and from this point here again, and I will take R1 and R4, and all of them is sharing the same point with the voltage source. Okay, so I can reduce or simplify this form or this circuit, this drawing, to this drawing. Now I can actually determine the combination of voltage across R1, R2, R3, R4 using Kirchhoff divider rule. So I see that for these two, for R1 and R4, they have the same voltage from this point, all this point. See here, I just take the E from the left side, and here I have this voltage V2 and V3 plus, you take the plus, is the same as V1 plus V4. Okay, so which is equal to 40. Now because these are series, so you take Kirchhoff voltage divider rule to calculate what is the voltage over the R2 and what is the voltage over R3. Okay, very easy. Now to find the current, you first draw the circuit, again move the branches all the way left and reduce the circuit to a series circuit. So reducing the circuit to a series circuit, you will know what is the information that you want to take and where is the current come from to each point of the circuit. Okay, so for the voltage, to simplify what I speak about, for the voltage you take the Ohm law if you have if you have the current and you have the resistance, or if they are in series, then you will take the voltage divider rule. Okay, if for the current, if you know the voltage and you know the resistance, then you will take use the Ohm law. If you don't have it, for example they are in parallel, then you will use the current divider rule. Okay, so for example here I will use the current the voltage divider rule, sorry. So I want to know what is the voltage across R2 and R1. However, for the current here, this one is in parallel with these two, is in parallel with R4. So the current is different. So I1 here is different than I2. So I use the current divider. Okay, after calculating the total resistance here. Okay, now there is another thing called the bridge circuit. The bridge circuit is it's like this, like the drawing, you see it here. So I use two equations to calculate. Here I have R1, here I have R2, Here I have unknown resistor. I use bridge circuit to calculate or explore or to know what is the value of the unknown circuit. Here we have a potentiometer RS, which is have a values from 1 to 0.99 or 0.9999. So this is like a potentiometer. You can change the value for RS. Okay, so here this is called the ratio R, so R1 over R2, and here we have the potentiometer. Here we have the Rx, the unknown resistance. So if I give you R1 and R2 and I give you Rs that we specified, then you can calculate the Rx. If I put 999 in instead of the value that you give it, this is called the Rs max. Then you will have the maximum value for Rx. So this circuit holds, okay, and everything is as calculated. So let's see an example. Here he gives you the R1, R2, and he gives you a value for Rs. So you just use the equation, very simple, to calculate the Rx. If he asked about what is the maximum unknown resistance, then you will take not the value that he gives to you. You will take the value of 999, which is fixed in our book. So you calculate the Rx max. Okay. Thank you very much for listening.